Hello, in this lecture we are going to look at a special form of the Carnot map which is known as don't care conditions. So what exactly is this don't care condition? Now we know that when we have a function on some variable, say x and y, I have a function. So these are the possible options. Now I know that for some combinations of the input variables I get a 1, and for some others I get a 0. But it may also happen in certain cases where I have the values for 1, I have the value 0, but for some conditions or for some combination of the values of the variables, like say for x and y, I don't have any value specified out here. So there is nothing specified out here. So it is neither a 0, it is not a 0, neither is it a 1. It's not a 1 nor it is a 0. So in such a situation, we say that this function is known as a incompletely specified function. So this is known as a incompletely specified function. So here it means that for the two variables x and y and the function f, 0, 0 is 1, 0, 1 is 0, 1, 0 is 1, but for the combination x is equal to 1 and y is equal to 1, we do not know what will be the value of f. It can be 1 or it can be 0, but we do not know. So it does not make any difference as to if the value is 1 or if the value is 0. So here you can see this combination 1, 1 is a incompletely specified function. So for incompletely specified function, the combination of the values of the variables for which the value is not specified, like here the value of 1, 1 is not specified, then we say that the mean term for this is known as your don't care. So don't care. That is, you don't care what is the value for this combination 1, 1. So this is known as a don't care. So now let us see how we can use these don't care conditions in order to simplify your function. So let us take a function which is given to us. So we have a Boolean function f, which is an incompletely specified function. So f on the variables, let's write the variables also, w, x, y and z. So this is given, the mean terms are given as 1, 3, 7, 11 and 15. So it means that out of 16 combinations for f, okay, the values which are 1 are 1, 3, 7, 11 and 15. Also along with this, we are given another function d, w, x, y, z. Okay, so this is the set of don't care conditions. So for which terms, which are the mean terms which have don't care values, that is, we have 2 and 5. So we can write this like in this way. So w, x, y and z. I think it is better we write it in the next slide. W, x, y and z. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't think we have enough space. 12. We'll write it here. 13. 13, 14 and 15. These are the possible combinations I have, mean terms. So for 0, the function, you can see the function d here says for 0 it is unspecified, 2 is unspecified, 5 is unspecified. So for 0, we don't know whether the function will be a 0 or a 1, so we put a cross. For 1, if you see the function, for 1, it is a 1. So 1 is a 1. Then I have 2 is also not specified, so 2 I put a cross because it is not specified. I don't know 0 or 1. Then 3 is also a 1. 4 is neither here in F nor in D, so its value 4 value will be 0. 5 is not 5 is again a don't care. 5 is again a don't care. Then ones we have 7, 11 and 15. So 7 is a 1, 11 is a 1, 15 is a 1, and don't care already 3 we have, and the rest 5, 6, 8, 9, 10, 12, 13, 14, these are all zeros. So for these 3 terms, combinations, that is 0, 0, 0, 0, 0, 0, 1, 0, and this would be, this is 5, I think, if I'm not mistaken, 5. So 0, 1, 0, 1. For these combinations of the variables, the function does not specify what would be the value, whether it will be a 1 or it will be a 0. So we can use these don't care conditions to perform our minimization or simplification of our functions. So let us draw the Kernot map for this. So 4 variables, w, x, y and z. So w, x here, y, z here, 0, 0, 0, 1, 1, 0, 1, 1. So I have a 1 here, I have a 1 here, I have a 1 here, 1, 1. Where do I have a zeros? I have 0 here, I have 0 here, I have 0, 0, 0. Here also I have 0, 0, 0. But for these terms, that is 1, 2, 1, what were the terms? 0, 2 and 5, 0, 2 and 5, I have don't care. So I'll put a cross out here. So for this I have a cross. So now let's see how are we going to minimize this. So for this we have to group the ones. Now here the advantage of the grouping with the don't care is that I can consider these don't care conditions to be a part of the group. So I can make a group like this, group of ones. Okay, similarly I can make a group like this. So I have 2 groups now. I can use this for the minimization. So for the first group I get w dash x dash. For the second one I get yz. So my function has been minimized to yz plus w dash x dash. So what we have done here, x here and x here are not ones, but it can be 1, it can be 0, we don't know, so we can use it for the minimization. Now one point to remember is that here you see this x is left behind. Now if it was a 1, we will have to include all ones. But since x here is not a 1, okay, if any of these crosses or don't cares are left behind, then we are not bothered with that. We can ignore this one, this x. We will only use those x which will help us to form a bigger group, form a large group. And if any x is left behind, it is not of any problem, so we can keep it as it is. So with the help of don't care condition, we can see that we have minimized the function f to this.